Hi everyone, it's Patrick here again from Eramosa Engineering. In this tutorial, I'm going to introduce the calculation engine within e.RIS. I'll show you how to create a very simple calculation that just takes a value from a SCADA historian, multiplies that value by 10, and then outputs the result to the MySQL database. So that sort of calculation may not have a lot of real-world applicability, but the reason I selected that was so it'll give us a chance to just see the fundamentals of how the calculation engine works without worrying about any complex programming. And it will also make it really easy for us to compare the original values that get inputted into the calculation to our final output results. So here we are on the welcome page, and we just go to the navigation bar, click on calculations. That'll take us to the calculations page. And immediately we see all of the calculations that are currently within the system on this server. So I'm just going to click Add New Calculation, and that will bring up this calculated tags portlet. So in this portlet there's three tabs. There's the general settings and versions. That's where we create the name of the calculation. We set a lot of the primary configurations for it. In the variables tab, that's where we create the input variables and configure those, and we create the output variables, and we create an output tag. And in the edit/test/view tab, that's where we'll actually create the program itself. The calculation engine that e.RIS uses, it's based on a programming language called MVEL, which is itself rooted in Java. So it doesn't require a huge background in computer science or anything. If you can learn some of the basic syntax of MVEL, then you'll be good to go. So I'm going to go back to the general settings and versions, and it always comes up with this generic name for your calculation in case you don't put one in. But we'll just delete that, and we'll call this simple demo calculation. And then we can put in a description. We'll just say multiplies value by 10. And I'll change the calculation type to automatic. That means that when the calculation is enabled, the calculation will automatically perform at regular intervals that we choose and that we configure on this tab. But I'm just going to leave the other settings in this tab for now. I'm going to click Save. We'll come back to this tab at the end. Now we'll go to the Variables tab, and this is where we're going to specify which data values we want to be incorporated into our calculation. So this first field, this is where we create the name of the input variable that we're going to use in our code. So I'm just going to go with very simple, boring name input variable. And then from this drop-down menu, this is where we choose the actual tag within the historian that we're going to be pulling our input values from. We'll just use this airflow tag again. And I'm going to choose interpolated sampling mode. I'm going to go with a sampling interval of 1 hour. Now these query start offsets and query durations, this gets a little tricky, but to explain it just quickly in general terms, each time the calculation is performed, it has with it associated reference date and time. And the query start offset will specify the relative time period, relative to that reference date upon which the calculation will be performed. So if I select 1 hour and a query duration of 1 hour, that means whenever the calculation engine wakes up, it's going to look back at the value from 1 hour ago. And it's going to take that value and it's going to insert it as the input variable for our calculation. So we just click Save. So that now shows all of the specifications that we've set for the input variable. And now we're going to create the output variable. So in this first box, we'll just call it output variable. And the tag provider, we'll leave it as the e.RIS tag provider. That's the MySQL database that all the results from the calculation engine get published to. And here we actually create a new tag that those calculation results will be stored under. So you may have a set of rules by which you have to create tag names, but in this case we're just going to call it demonstration tag times 10. I'll just leave the description for now. We won't worry about the engineering units, but if you wanted to, you could put in liters per second, megaliters per day, whatever your output variable will be in. We'll just leave the decimals to 4 decimals, and we're going to change the offset, the save offset, to 1 hour. So that means every time the calculation performs, it's going to timestamp the result of that calculation to 1 hour prior. And then we'll click Save. And now this will take us back to that Variables tab. And it shows us the input variable that we had before. And now you see the output variable in this lower row. Now is the part where we can create the actual code that will perform the calculation. So on the Edit and Test tab, there's a couple of sections here. This large section here that's just empty space, this is where you'll actually write the code itself using the MVAL programming language. This pane here is where you'll perform a test on your calculation to make sure that everything's running properly, that your syntax is correct, that everything's lined up nicely, and that your calculation will perform correctly. And there's a little hidden feature here. If you click on this left border of the editor panel, then you get this nice cheat sheet that flies out. One of the nice things about this is it shows the names of the variables that you just created, so you don't have to flip back in case you forget the names. And it also gives you some good lists here of the different syntax that you can use. So if you wanted to incorporate conditional statements, if statements, for loops, that sort of thing, then you can find the syntax here and you can just copy and paste it. But we won't need anything that complicated for this one. So I'm just going to close this cheat sheet again. And I'm just going to put in the code here. It's going to be extremely simple. If I want, I can bring out that cheat sheet again. And this shows me the name of my output variable. So I'm going to put in the name of the output variable there. And then I'm going to put dot value. Because each variable has a certain number of properties associated with it, such as the quality rating, the timestamp, if there's a flag associated with it, we need to specify which one of those properties we're actually manipulating within the code. So in this case, we are actually changing the value of that variable. So that's why we do .value. And we'll just say that the output variable is equal to the input variable .value times, so the asterisk is the, just like in Excel, say that's the symbol for multiplication. And it's a good idea to terminate each line with a semicolon. Now we can hide that cheat sheet. And if you click on this right-hand border, that'll bring back the testing pane. Now I'm going to choose a day for which I know that data exists. And so this is the moment of truth. We click Run Test. We cross our fingers. And it's a good result. So it'll show you warnings and errors. Warnings are little things. They don't prevent the code from working properly, but it does say that there's an adjustment that I need to make back on the first tab. And I'll show you how to do that in a sec. And other than that, everything looks good. So below here, this shows the value of the input variable that's coming into the calculation. It's 575.7229. And then up above here, we see a preview of the output variable, which is just that same value times 10. You just have the decimal moved over one. So that's a good sign. That means the calculation worked correctly. So we'll click Save. Now I'll go back to the General Settings and Versions tab. Now, because I'm taking the value at every hour, that's what I've specified in the Variables tab, I want the calculation engine to run at the beginning of every hour. So that's where you, this schedule here is where you set that. So I will choose this 00 under the minutes section, and it's nice up here you get a plain language description of what your schedule is going to actually do. So this is what we want. We want it to run every hour, every day. Now this is where we want to, this section is a little tricky. We want to change this last run date. The last run date is when the calculation engine wakes up, it will automatically go and look at that last run date, and it will check to see if there's any outstanding calculations that need to be performed at that date and time. And if there aren't any, then it will progress forward. It will look forward in time to see if there's any calculations scheduled after that, and it will perform all those calculations that are still outstanding. It can get a little complex. It's described in pretty good detail in the user manual. So for now, we'll just change this to September 1st, 2009 at midnight, because I know that there's data for that tag at that time. So we change that in these update boxes, and when we hit save, it will automatically change this last run value to what we had set there. So now the last step of configuring the whole calculation is to set the effective dates for this version of the calculation. Because any calculation can have a number of versions. If something changes over time, you can still preserve the overall settings of the calculation and just make minor tweaks and have that as a subsequent version. And this allows you to set the dates for which each version is effective. And if any of the dates overlap, e.RIS will honor the version with the highest number. It will take precedence. So I'm going to just set this one effective for a narrow window of time. We'll just do 2 days. So that's all set. I'll click Save. So everything's looking good there. Now, in order to actually publish the calculation, there's 3 toggle switches that you have to enable. So you have the toggle switch here for the version. So we're on version 1, we want that enabled. And now we want to enable this toggle switch. That will enable the calculation as a whole, this calculation called simple demo calculation. And I'll just save that. And we want to make sure that this one up here, this is kind of the master toggle switch for the whole calculation engine. We have to make sure that that's enabled. Now, the calculation engine, it ordinarily schedules to wake up a half hour after the last timer performs an action. But if you don't want to wait that long, you can just hit Run Now. So you'll see the status changes here. And it will show you, it'll give you kind of a play-by-play of what the calculation engine is doing at any moment in time. So you can see that it's gone back, it's looking at September 1st, 2009, and it's evaluating this calculation called simple demo calculation that we just created. And you can actually see it advance through time through the hours. So now it's at 2 o'clock on September 1st. So that's going to take just a couple of minutes, so we'll just pause the video right now and we'll come back in a minute. Okay, so our calculation engine has completed. So I'm going to click on Data Query and we'll be able to actually view the results just like we would if we were pulling values from a SCADA historian. So first I'm going to bring up the original input variable data. So I'm going to bring in, this is our tag that our calculation is based on. I'm going to set that to a 1 hour interpolated because those are the values that we used in our calculation. I'm going to add another item here. And this time I'm going to choose it from the e.RIS tags because that's where the results of our calculations are stored. And I can see there's the tag that we created right there, et.demonstration tag times 10. And this one I'm going to leave at raw sampling mode because that will show us the complete list of all the values that were calculated, which is what we want. So we've got our 2 tags there. I've selected this date, that's within the range that we were calculating for. Hit Run Ad Hoc Query. Scroll down, and then there you can see in this left column here, those are the original values. And then over in the right column, those are the same values multiplied by 10. So it was a very simple calculation. Didn't require any serious programming background. You could use a similar type of idea to convert between units. If you want to go from liters per second to meters cubed per day, you just apply the correct conversion factor instead of using 10. And in later videos, we'll show how to create more complex calculations. So we'll see you in the next one.